bit better. Let's get into question booklet number one. Question number one, we're going to rocket through this one because it's literally the same thing every year, except for that 1 year there was a first principles thrown in for fun. So this question is all about, welcome to the exam. Did you pay any attention during the year? Please say yes, you did. So just here are some differentiation questions to do. Sometimes it's an integration, but let's do some differentiation just to warm ourselves up. Here's a nice friendly logarithm. Now, I get stuck into that one. Obviously, if you're not so familiar with the log laws or confident with it, students who weren't so confident with it, or maybe just panicking a little bit, it is only question 1A, they maybe use the log laws incorrectly. So just worth being aware of that. In part B, we had a question of function that required a little bit of work to get it into a differentiable form. Those students that explicitly wrote out that working form, 4x to the power of -1 plus, in brackets, 7x plus 1 to the power of 1/2, typically did better than those that skipped over that step and said, I know how to do this one, and then they got it wrong. If they also incorrectly used the chain rule, which is a very easy thing to do, they didn't get full marks for it. The two most common things there were mucking around incorrectly with the power, so not dealing with that power shift down and change that first power to by 1. And of course, the quintessential forgetting to multiply by the function on the derivative of the inside function. With my class, I often talk about inside function and outside function. I find that's a useful analogy to use. Some of them like it, some of them don't. Finally, in part C, a nice little quotient rule question. The one thing that students did, we always have students that like to try and turn this into a product rule because they feel happier with the product rule. But if they write, u is equal to, the sign whatever, and then v, turning that into so bringing that 8e to the power of x up, if they did that, they did not do very well on this one because that is not the product rule form for the v function there. Okay, very easy thing to do. You want to do it because it's a power, you want to make it negative, but fundamentally, as I'm sure you're all aware, it should be that.
I'll just say, obviously,
Yes.
just because it hasn't been said, if they implement the product rule correctly, they're still going to get all the marks, of course. It's just like it's the less than optimal approach to get through this question.
Yeah, sometimes it does make it a bit easier. Not in this one. That's question number one. Any questions? Yeah.
And if they see the kind of the might be they can opt.
Yeah, so look, the question says you do not need to simplify your answer. If they do go ahead and simplify it, they go, wow, this looks really ugly, there. They can certainly try and make that look a little bit nicer. There's nothing wrong with that. It's just a waste of time.
And like the exact breakdown on how the marks, we don't necessarily know, but like it's definitely not like 100% correct for like 2 marks. And then like if you don't get 2 marks, you get 0 marks. You can definitely get part of the marks by doing part of the stuff.
And I think one of the principles that Deanna has told us about is that you can't wreck your answer. So if you get the derivative completely correct and then you try and simplify and mark that up, I think you would still be earning the mark for that one. All right, question number 2. We've now got a friendly little continuous random variable here with a nice little function. And we're seeing just some nice calculator stuff to get us started here. So again, not much space, 1 mark. Just give us the answer for that one there. But then in A part 2, it's asking the students to interpret the answer in the context of receiving the order. To earn that 1 mark, that answer needs to actually have a little bit of information in there. It can't just be, any one of these things. We kind of need to talk about it being a probability, explicitly making that connection between the definite integral of the function and probability. We need to see that it's between 2 and 5 minutes, right? What's the 2 and the 5 doing as part of that definite integral? And they need to give some indication they know what's happening within the 2 to 5 minutes. So they need all three of those things. Now, there's some flexibility in terms of the words that you use. The probability of getting their meal in 2 to 5 minutes says the same thing. But fundamentally, 3 aspects to that answer in order to get a really good result.
You might think it's a little bit harsh, but it is always one of those things where, like, you can't, like, you imagine if you're writing a test in your classroom, you wouldn't want to give that 3 marks either. And even like the intelligent student, I imagine, would have looked at the description in B part I above, which essentially restates the context of an example and then just pushed it back into their answer to that question anyway. So although it didn't feel like a lot of marks, I think it was probably a right move.
Then in part B, another quick calculation, this time stating an integral expression and then doing a little bit of colouring in, followed by the more tricky parts of this question. This question was done quite well up to this point, and then wheels started coming off for a few of the students. There's just some interesting things kind of going on with that 0.3. Some students multiplied by 0.3, or negative 0.3, sorry, to get negative 0.9 e to the power of negative 0.3. And some students just completely forgot to do anything with it at all. And then, as I'm sure you're all expecting, that plus C got dropped off by many students as well. The plus C isn't always marked in every single question. It's not like if a student has not been taught it that they'd get punished, every single time it should be in there. But this is certainly a good point for it to be, because it's not that difficult an integral. Those students that got that question wrong often struggled in the next part because they'd come unstuck in certain parts. So, one of the key steps in here is going to this point here. I've been talking with my class about solving exponential equations. We always want e to a power in order to solve that, to take ln of both sides. But if you're getting e to a power is equal to a negative, well, clearly that's a point to stop and think and go, hang on, that's not right. Whereas we did notice some students just sort of ploughing on through and ultimately getting towards a negative answer, which if you look at the question, we're after probability, it should definitely be positive. Dan.
And like the other big thing is sort of around here, if you just subtract 1 off of both sides, you'll end up with a negative e to the whatever is equal to negative 0.2. And technically at that stage, you can't take the natural logs of both sides because they're both negative at that stage, which has led to lots of strange things happening, I imagine, to students' calculators and things like that. So you had to do the removal of the negative before you implemented the natural logs of both sides.
And this question is asking for the exact value of R. The exact value can look like any of those options there. There's no one specific form, as long as it's the right number. That's about it.
It can look like probably a million other things as well, right? But that's just a couple of good examples that I put there that you can imagine would have came up. Hi.
All right, that's question 2. Would we like to clarify anything? This is booklet 1, so you get to do this. Booklet 2.
Booklet 2, I'm smashing through it really fast.
Yeah. All right.
I can already feel it coming.
Question number 3, nice little first principles bit in here. First principles in this course has typically been rational functions and radical functions. Can even combine those ones, I guess. This is the second year that we've seen a first principles for a quadratic, which is very friendly. The difference here is, and I guess the thing that's sort of bringing it up in complexity, is the fact that there is a parameter k floating around in there that students also need to navigate. Students did that with varying levels of success. So there's probably a couple of things to talk about with first principles just in general. When we're looking at these 2 steps in here, so going from an expanded numerator into the next 2 lines, what lots of students did was go from there, let's cancel everything out and get straight down to there. They really need to do that in 2 steps to show their understanding of the first principles process. They need to step that out so that we can see, let's cancel out all the common factors. Okay, now we can do that. Now h is a common factor of the numerator and denominator. Now let's cancel that h out. Dan.
I always think of these questions almost like a show question, essentially, where students have to, and by the way, something that Tim hasn't said earlier, I guess we've got to always remember in this forum, there's a lot, I know a lot of you from previous years and been up here, but there's a lot of new teachers as well. So some of the stuff we have to go to those sort of levels to make sure they understand as well. But yeah, the onus is on the student to show that they've found this derivative using first principles and not use just one of the rules. So like, I talked to my students this year about like, that's your responsibility. If I feel like you've just differentiated it using a basic rule, you're not going to get the mark for it.
Yes.
The second thing that students often do is forgetting this equals lim h approaches 0. They drop it off. It is tedious to write at the start of every line, but they need to put it in there until they make it equal to 0. That was part A of this question here. Now we're getting into the next part, and we see here we've got a nice tangent forming, so we're obviously going to do something with that. We have a show question. Show the tangent has this particular equation here. Look, there's multiple ways that you can go through this. The Hayes textbook has got a very short, sharp and shiny way to get into that tangent formula. If you're using that, which is this version here, you do need to do some expansion to make sure that it's very clear how we're getting from just chucking some values into the formula to that form that is being requested. We've got our other 2 formats here that just sort of naturally do that anyway. I always encourage my students as well, explicitly and separately, writing out, in this case, f of 2 and f dash 2. So making sure they've got the x-coordinate, the y-coordinate, and the slope of the tangent at that point clearly written. Then they just start putting things into the formula and off they go. Some students, just some common errors that we saw, didn't even bother to write y equals, which was very upsetting. And then the other thing that some students did was, if they didn't write out this stuff here, particularly f-2, when they're using, and I guess it's probably particularly the Hayes formula here, instead of writing 4k, they wrote the derivative function. It's really important when you're writing an equation for a tangent that there's only one x, and it's this one right here. Another thing worth making sure that our students are aware of. Finally, we've got a very simple, here's a y-coordinate, what could the value of k actually be? So really just recognizing, oh look, here's our function. We've got our y-intercept is -4, k plus 1. So clearly, well, that has to be equal to 11. A very basic algebraic problem that probably because there's a few negatives floating around, some students did struggle with. And instead of getting to this point here of -12, we saw -10 a few times because we just didn't work with negatives very well.
It's amazing. Like that's the kind of thing that I would stuff up when I'm teaching a lesson. You know what I mean? You relax. You've done all the hard part. You go, all right, I'll just substitute in and solve it, and then you stuff up the numeracy at the end of it. So, yeah, it happens.
It does. All right. Were there any questions about number 3? Very good. Number 4, our first real context, I think, or at least the first context that has a pretty picture. So we've got astrocats happening here. There's definitely some copyright going on. And this is, look, honestly, a very routine binomial questions. Let's just get our calculator out and punch a few things in. Students still find this more than 2 gold cards, just sort of turning that into, working out where the first included boundary is, where the last included boundary is as well, and sort of what we're doing there. So it is important to make sure that our students are keeping their eyes on that.
Can I say one thing about that one just really quickly? That question was like a nice example of what I imagine to be something called like a final answer only gets 2 out of 2 marks, right? So you can imagine, and you look at all past exams, these ones where you've got to do that slight swap over due to the discrete nature of the random variable from like greater than 2 to greater than or equal to 3, there's like a mark bundled up in that, as you can imagine. But if a student just went on to literally state the answer, they wrote nothing except for 0.0042a. Like, there's no way in hell that they just made that number up out of the middle of nowhere, right? So they must have had understanding of what the hell was going on in this question, and they'll just get both those marks, right? So there's no expectation. There's no expectation of them actually showing the working out. But I would encourage my students every day of the week to show that working out as well.
So showing that working out, just to clarify, Dan, you mean showing that little bit I just said?
Yeah, something like that. All right. We often argue with the amazing Valerie Frost about this when I used to work with her at a school. I like my students even write their graphics calculator input on the page. It's like not going to ever get any marks, but like it just helps formalize the process, I think, and it just stops them making silly kind of mistakes.
So if I just write BCD in 3, that's acknowledging the 3 card, correct? Do they need to write PMR X greater than written?
No, I don't have to write that. No. All right.
Hang on, Dan, just to clarify, because that sounds like calculator notation.
Yeah.
We're using BCD bracket 3.
Like, some of my kids won't write the X is greater than or equal to 3,
Yeah.
but they'll write the BCD, 3, comma,
Whoa, it's a,
and they just won't get the answer.
first of all, like if they got the correct answer, they wouldn't need to have, wouldn't matter what they wrote. I don't know what would happen if they didn't get the correct answer, because like they always talk about it if like they don't mark graphics calculator notations. I don't know if they'd have a consideration of the fact that they've shown understanding that the limit swaps over to 3. I don't know. Yeah.
So you expect it not PMR X greater?
No, that's just me being a mathematician that doesn't want to be too embarrassed up here of what I've written. So, hey.
I encourage my students to write the PR X greater than 3.
Right.
So one of the insurance.
Yep.
You write that stuff. I mean, they pick up, that's the way, right?
That'd be
Yeah,
the
one
one.
is 2. Yeah.
But some of my kids won't write that, we'll just write BCD,
Well, no,
3, comma, the 3 they're showing the outstanding 3.
You won't get large week, right?
Yeah, I don't know. And if you don't write the R after the P, that's okay too.
One big maths. That's.
There was a question at the back.
Yeah. Why is 5 over 2 marks, but the other one's no?
This one is because they do have to do that translation. So we've got more than 2
To
and so we're
3
making a
to a
change,
probability.
and then the calculation. So effectively, it's 1 mark for recognizing that 3 is the lowest included value, and then the answer.
Where with the second one, it's already at least 1. So there's no changeover of a variable of the number in that case.
All right. In part 2, we've got now some packs of cards getting brought in. So we're just having to recognize that we're now talking here about out of 120 cards. So really delving deeply into the context here to get this particular number, 0.986. And then that whole idea kind of continues on to the next part. So now we're talking about a collector making some claims and doing some investigation, and they have 1,200 packs of 10 cards, and they've got 51 of these special cards. What is the population proportion? So what is the sample proportion here? They really needed to sort of tease that information out of 1,200 times 10 from that information that was provided. Then we get a nice confidence interval, and sometimes students like to write out the whole calculation for the confidence interval. There's no need for them to do that. The 2 marks here are really for the boundaries and for knowing what we're actually talking about, which in this case is the population proportion. Students still love writing all sorts of weird and wonderful things here. P hat, mu, that's an upsetting one, X bar, or whatever else they feel like writing there. They need to show that they know this is for a population proportion. Did I cover everything there, Dan?
I think so.
No. You interrupted me at that point last time.
Did I? Shit,
You did.
all right.
Yeah.
I'm sorry for my past.
That's okay. That's right. You get a chance to interrupt me again now because we're looking at assessing this claim. Dan, you're the master, so I'm going to hand it to you.
Oh shit. Okay. I do apologize. I'm feeling slightly under the weather, so my brain's not working that well right now. But so with these ones here, what I said last time we were here is the idea that I think shorter, the better. What this actually goes against something you were saying earlier a little bit, but like, if you directly contradict something you've said in the past, you can unearn a mark. Like if you truly smash your old thing apart by saying something, so for an example, you might say yes and then write comma no. Maybe you could get the mark, right? Because you get it both ways, yeah? Because you can't unearn the mark. So like sometimes if you directly contradict what you've written before, you can lose the mark. And often with these confidence intervals, students go hard with definite statements. So for example, like the answer here, there's always a yes, no kind of thing at the beginning of these questions, and then like some kind of justification. So in this case, no, there's values in the confidence interval that are more than that, right? But some people, I just can't remember what the claim was, that there is no more, like the claim at the very top of this question, that there were no more than 0.04. A lot of people will write something like, no, there is less than 0.04. And as soon as you make a definite statement, you're out of the game, right? Because like you can only make these statements we can only support this claim with 90% confidence. We can't make definite claims. So like it's really subtle, but like you can say this no or yes at the beginning because that's in relation to whether you're supporting this claim with 90% confidence, but you can't make definite statements about the actual parameter, if that makes sense, right? Your no or yes is about the supporting. Now I'll look over to here at Tim Edwards and I'll answer that question straight after. Okay? Like sort of, this man's a wordsmith. If you can think of anything, you can say it after. Hey.
What I usually get my students to do is say there's insufficient evidence to support or reject that claim.
Oh.
Exactly, but because I think not even supports you, and you can't really reject stuff.
But it's always, from my experience, it's always a yes and a no, right? Because like this, what's the word I'm looking for? You've got your confidence level of your support, right? We're not 100% confident of supporting this claim. We're 90% confident. So the what's the word I'm looking for? That's sort of taking care of that in a sense. So I would steer away from that. We kind of support, we kind of don't support kind of logic in these questions. Okay. All right. I'm not sure if I've answered your question properly, and I do apologize if I haven't. Perhaps afterwards we can come up and have a chat, and I'll have another crack at it when we get into the confidence intervals in the second booklet too. Cool.
You have two chances this one.
Yeah, two chances. That one's half a swing and a miss.
The general advice I give my students is keep your answers short as possible. So your answer is always going to be yes or no, and then a reason talking about the number of the claim and whether there are values above or below, or whatever's going on in that situation. Some students also have this misconception that if the claimed value is inside the confidence interval, that's an automatic support. That case, they clearly don't really understand what's going on in a confidence interval in the first place. All right, any other questions for Dan about confidence intervals? Excellent.
We'll come back to them as well, and I apologize that I'm not explaining it that well tonight.
All right, question number 5 after the working out page. Just a quick note about the working out page as well. It's some students might be tempted to write an answer to a question in one booklet on the working out page for the other booklet, and it's not ideal. It's okay, but ideally all of the questions that are asked within a booklet get answered within the same booklet. The SACE board has processes if a student writes an answer in the wrong booklet, of course, but it makes it easier for them effectively if it's all together.
It just increases the likelihood that it's not going to get missed because, as you maybe know, at SACE they break the marking into 2 booklets. So like if you're a marker, you mark booklet 2 or you mark booklet 1, and imagine like you just become disconnected of all the stuff that's in booklet 1. So you're not going to know if there's kind of some random mass on a page necessarily and instantly link it to a question in booklet 1. Now, like every attempt is made, I imagine, by SACE to make sure that it is always flagged, but it just increases the likelihood that it's going to be seen always. So,
and particularly important to write the question number as well that they're asking. I know it tells them to do that, but sometimes they don't read. Question number 5. As we read through this question, and I always encourage my students, they don't get reading time anymore, but it's so worthwhile to have just a quick flick through the exam just to sort of see where things are at and, where things are, like the conjecture question. When you're looking through here, you start to see that, that table coming up and the word conjecture, so you kind of know what this question is about. This question follows a very standard pattern for the conjecture question. Parts A, just part A, but part 1 and part 2 are your preliminary sort of problem, followed by let's look at a pattern, make a prediction, and follow it up with doing the proof. We've got a show question first of all. So clearly we need to see some very clear algebraic evidence taking one step at a time. One thing that students did was they saw that we had a rational function plus another function, so fraction plus a thing. So they went, let's write that as a single function and then use the quotient rule on that. And that actually made it more difficult for them. This function 2 on x minus 1 can be turned into a function to a power 2 times x minus 1 all to the power of negative 1. Then it's just a little bit simpler to work with. So I think students that recognized efficient ways of working in this question were really rewarded. Students who tried, I guess, the more brute force methods, many of them were still successful, but they lost their way sometimes. So making sure that things are really clear in part 1, then in part 2, an algebraic approach. So we've got exactly 2 stationary points. If at all you're tempted to just find f-0 and f-2 and say that they're equal to 0, how do we know that there aren't any more? We don't, because we haven't done the necessary work to show exactly 2 questions. 2 stationary points. Going over the page, we've got a table and we've got a conjecture. This was done phenomenally well. It was very, very pleasing to see most students go, hey, there's a very fun pattern here. And, using their calculators to get those values as well was really, really, really good. And then on the next page, we have this absolute work of art. Dan, I think this is probably the most number of variations that I've ever seen for a question.
I'm sorry my writing gets real small as well. I actually enlarged all of my writing as well at the request of Massa, because it was smaller than this. And I just zoom in on my iPad and just write even smaller. So sorry. If you can't read it, let me know. Yeah, I think this question is now known as the question with the most varying solutions possible. There's lots of really clever and beautiful ways of getting to this. There's lots of ways of crisp factorizing. There's lots of ways of quadratic formulas and different types of quadratic formulas. Yeah.
Dan, you had too much fun with this.
Hey, I could do more. Hey.
I know you could.
Hey.
So look, I'm not going to run you through all of the different solutions, but fundamentally, making sure that they're finding G dashed, that they're, getting it into a form where they can solve that equation, making G dashed equal to 0 and getting some answers. Of course, lots of students, when they get to, a stage like this where they've got to take the square root, we all know they totally forgot that you can get the plus or the minus. Oh, it breaks my heart. Anyway, any questions about question number 5? Fantastic. All right. Final question from booklet number 1 is question number 6, and this is a reasonably friendly function with a nice little twist. We actually have now what is it? It is a oblique asymptote happening down here. It's the words for that aren't used, but if you know your way around asymptotes, you recognize it. That does a couple of funky things in the latter part of the question. So we've got a sign diagram to draw. Sign diagrams are still a point of pain for many students. They obviously need to recognize that B and D are the only points where the derivative is equal to 0, and making sure then their signs are accurately arranged around that. These just tick some boxes, so make sure you tick a couple of boxes. Hopefully they're right. Part C. Be
careful with your negatives and things like that.
Yeah.
Those ones there.
Part C. Now this was a really interesting one.
Right.
I hope I'm not the only one that does this. I hope this isn't mathematically, wrong. But when we talk about increasing and decreasing in terms of our function, I'm certainly a little bit fast and loose with whether that includes the boundary points, so the maximum. So whether we're talking strict inequalities or inclusive inequalities. My personal perspective is it doesn't matter in that context. Here, the question is saying, state the intervals where f, the second derivative, is greater than or equal to 0. So students needed to use an inclusive inequality to recognize this, so I guess to denote those boundaries.
I'll say one quick thing. From past exams, and I've seen people up here as well, like SACE doesn't seem to mind if you include the equality or not. Obviously, with the exception if there's an asymptote. That's like the one case, do you know what I mean?
That's the increasing, decreasing.
Yeah.
We strictly decrease.
Yeah. So that's yeah. So I'll just repeat if you can't hear Alice there. That's like, sorry, and I should have clarified that a little bit clearer. That's from words to symbols. So I say, where is it increasing? Imagine this question was written like, where is it concave up? You could have the inclusive of A and C or not, because it's words to symbols, right? But because it's up here and that little green thing up there, it says greater than or equal to 0, then you better damn well include those limits. Right. Yeah.
Finally,
thank you, Alistair.
Finally, we've got a sketch of a graph. There's a couple of really obvious things that we need to include here, making sure that we've got our max and min in line with A and C, making sure that our zeros are at B and D. And then we just need to make sure the shape is valid. And, when you look at this set of axes before you've written an answer on it, there's a really interesting thing happening down here. We've got this K floating around. Nothing that's put in this question is there by chance. The K is there for a reason. And so if we dig back previously, we noticed that the slope of the graph, I think it approaches Kx. I forget how it puts it exactly, but it makes it clear that we have an asymptote. We've got a point here where we shouldn't be going below K. Now, whether you draw this as a clear asymptote or whether you just you're vaguely going down.
I know that. We shut it and that's at the Korean spot.
Oh shit. I'm gonna be quick.
You got to take real quick down.
Listen, you didn't need to see the dotted line.
No, there's no requirement of the dotted line. Yeah, but again, like what Tim's saying, just because it does asymptotically approach it doesn't have to be that evident right here. So as long as it's like the Ghostbusters stream. As long as you don't cross over this, you're not going to die, right? I guess, and some other things about this one, a really nice way of thinking about this stuff for your marking for your tests is say, for example, this minimum. As long as the minimum is closer to A than any other grid, that's kind of all right. You know what I mean? And there's a million things you could add. You could make this thing out of 25 marks if you wanted to, because for example, the magnitude of the magnitude of the y coordinate here should be smaller than the magnitude of the y coordinate here, because the slope was less steep negative than it was positive here. But we have to draw the line somewhere, right? So generally, it is what sort of Tim is saying. You got to probably hit the max and the min and the x-intercepts and have it not cross over that dashed line.
The other thing that is really worth being aware of is that the graph does need to go pretty much from the end of the axis to the other end, because if it doesn't, how do we know what's happening over there? How do we know what's happening over here? So students need to demonstrate that full understanding across the whole thing. And that's all from me for question numbers 1 to 6. Dan?
Cool. Wish me luck, people. I apologize for how quick I talk and trying to get through an entire booklet in 30 minutes. No, you can interrupt if I say something wrong, most definitely. And at least you guys are the lucky people, because last time they didn't have a copy of this. Remember, you guys got something for free. All right, question number 7. I'm just going to do this. This is going to make a crazy creaking noise, and I apologize. Told you. So just really quickly, this question is a pretty run-of-the-mill kind of question. So even the average for this question, if you have the examiner's feedback here, it's pretty similar to the average of question number 3, because there's just so much technology stuff at the beginning of this, right? Just some basic normal calculations. So no, there's a question I got asked last time. You don't need to define what X is. I would encourage my students to define it. But if students just pulled X out of thin air, which we all know they do, you're not going to lose a mark for it. These are again examples of final answer only. All you really need there is the 0.632, I imagine, and the C is equal to 25.3. I guess in part there, students just chose the wrong direction at times. Down here, I think students see part B, or my students do, and they think, I'm just going to write central limit theorem and cross my fingers, right? But this one, if you actually know, it's technically not central limit theorem, by the way. If the original distribution is normally distributed, it's just like a linear transformation of it, that it stays normal. But in our case here, you just had to write something, I imagine, about the individual, the daily, not cows, the individual daily production of milk was was normally distributed, so hence any number bigger than it will be normally distributed, right? All right, over here, some simple kind of show stuff just designed to set up those next questions that were coming. And I use this a lot in my tests, for example, just to normalize the different types of answers I'm going to get here and not get like craziness always. And it just allows that, again, what Tim was saying here, allows that re-entry point back into this question. Again, the examiner's feedback comments, this was done really well. Construction of a confidence interval of all the same kind of stuff that Tim said earlier. You can imagine 1 mark for the limits, because if you get one limit wrong, you're going to get the other one wrong, right? Because of how you use that formula. So you want to give that 1 mark and then 1 mark for the notation around the middle. Tim didn't mention, but in my opinion, if you include the equality or don't in this one, I think it's okay. All right, confidence interval. Yeah, we're back already. This one here, so with this question here and the question down the bottom, they comment on this thing that students just write, yes, it does support the claim. And there's no words of claim anywhere in this question, right? And that's just students like cutting and pasting stuff off of their notes and hoping for the best. There's no mention of the claim at all here. And so so the confidence, does it support the feeding plan is increased? So an example of like a definite response would be, yes, the feeding plan has increased. Do you get that? Like it's just definite. Like you've undone all your good work in that sense, because we can't say it definitely has. We can say whether does the confidence interval suggest with 95% confidence that it's happening. We can say that, but we can't say yes, it has increased, right? So you've got to be a little bit careful around your language. Now, there's lots of ways you can answer this. Of course, you can say yes as all the values in the confidence interval above that. You can say yes as 21.9 sits below the confidence interval, and many, many other ways that you might be able to say it. Going down here, this question I imagine is just trying to set up the idea of, you've got like a different kind of metric here. You've got like the total milk production of a whole bunch of cows. So it's essentially getting that value and converting it back so you can match it up with your confidence interval and use that value against your confidence interval. Now, of course, you can imagine you could get that confidence interval that you have existing up here, all the way back here, and multiply it up by 90 and make a comparison to the claim, not the claim, I said it, I'm one of the students, damn, to the thing they're talking about here. So you could times both those upper and lower limits by 90 if you wanted to. But the question, I think, is set up designed to get that value down to being comparable and then compare that against the confidence interval on the previous page. So there's lots of, like, again, what we were saying earlier, keep your students' answers short and sharp, just so they don't, students will write beautiful things like this and then go on to say something that's really bad and wrong and definite, right? So keep those answers really short rather than letting them run really long. All right, questions about this one? Cool. If you want to ask after, we can stay in here, you can ask me questions when all the lights go off. I imagine it's going to happen at some point, right? The balancing robot question, I like to think of this one as like a kinematics question kind of dressed up, essentially, right? Some complicated, it's a bit tricky because you've got like negatives and positives and it feels all a little bit weird. But a nice little, what's it, damped harmonic function kind of thing, right? Over here. So this question, again, according to this, done pretty well up until the end of the point when it starts relying on the algebra rather just on graphics calculator skills. No, you didn't need to put the C there for radians. I just wanted to show off. So yeah, it wouldn't be required that. I always think the absence of units implies radians essentially. Just graphics calculator stuff here going in to an interpretation of a question. The interpretation questions are always hard again because again there's 2 marks here. You don't want to in the test, you don't want to give it 4 marks because kids just won't do it well. So yeah, basically you have to give it 2 marks and sort of hope. So I don't know how they break the marks up, but I tried to pick on all the main things, like the 1.3 seconds after the release, mentioning that it's a rate, of some sort, and it specifically comments on appropriate units, so I bet Dan will comment on that as well, right? I'm not sure how they kind of break those 2 marks into those pieces, whether they just bundle 2 up with the other, right? You know what I mean? Onto this one. I like this question. This question's like a little bit sneaky, right? Because it says like to the left with a maximum, which ends up being a negative and a minimum. And it just like made sure that students were actually reading the question and actually understanding the context. I thought it was like sneakily kind of nice, right? Over to this one, whether or not you agree, I don't know. So this one here over the page, improved model. This robot is now balancing itself really quickly. As you can see, it's improved, right? And now it goes into an algebraic thing. This question kind of dies before anything too exciting happens, in my opinion, as well. But find the derivative. Here presents a problem, I guess, that's kind of worth noting, and I imagine you guys would do this in your test. You can imagine students, unfortunately, not implementing the product rule here, and that just like feeds into part 2, just having a significant lack of complexity compared to like the proper solution. So you'd end up losing, in my opinion, you'd end up losing a few marks in the second one as well as the first one for not doing the correct derivative. But in our case here, the derivative at the top using product rule. Now, like any of the steps that are down the bottom around like the factorization and things could be done, obviously, I imagine in part 1. But in the second one, setting equal to 0, there can't be a mark for that because it damn well says it in the question that you're meant to do it. But in this case here, it's either like factorizing out the e to the minus t, or just dividing everything through by it. My understanding was there's no need to state that it's non-zero. I know I always get asked that question when I'm up here, but no. And then the final step, like we were asking it last time, like there's no, like from like around, I'm going to walk over here for a minute. From like these steps around here, like from this to that is okay, and from that to that's okay, right? It's all right, I'm pretty loud. And students, you can imagine, could do like the things we were talking with Alistair in his amazing session around just using solve-n to find the way to victory there. But what you can imagine, the questions, the graph is pretty dicey. Like it kind of like goes in really quickly, and you're like, oh, like, shit, is there another max or minimum in there? You can't quite see. So as they sort of comment in here, that because it wasn't visually obvious, there's a lot of just t equals 3 pi on 4 here, right? But the way I often think about that question, I think about the unit circle, and I think about the values of t such that cosine is a negative of the sine at that angle, yeah? Oh, cool. Any questions about that one? Sorry again, I did apologize in advance that I do speak quickly, but I've got 4 minutes and 2 questions. What could go wrong? All right, this one here, a strange question around a probability mass function. Probability mass functions normally don't result in the most complicated questions, but because this one has infinitely many possibilities for x, it's just, you can't use all the regular stuff you'd normally use to find the mean and the standard deviation and things like that. So it starts with some factorial notation things at the beginning here, but you could pretty much get away without using factorials if you're clever enough. You could have found the probability of x equals to 0, and then had one take everything to get the other one without ever finding 5 factorial. If you had like a nervous student with factorials, right? It comments here essentially that a lot of students just dropped 2 A's into there and just said all of that plus 2A is 1, and then got that answer, which is just clearly incorrect because they don't have to be the same value. Cool. Down here, just being careful with derivatives, because you got indexes and indexes, which just makes it confusing. And also, like part of me when I do this question is I want to make it equal to 0 rather than substituting in t to be 0, right? That's I'm so used to in this course just letting the function be 0 rather than t be 0. Lots of mistakes here, and you can imagine like good old fudge where students will find an incorrect derivative, sub in 0 on the page, and magically, even though it doesn't equate to it, just write a 2 at the bottom of the page. So like, yeah, you'd hope that you train your students up as like, the people at SACE must be smart. They're going to spot if you try to do that, so don't try and do it. But yeah, they should go back and find their error and try and fix their mistake rather than just cross their fingers. Maybe I'd cross my fingers too, I don't know. Product rule with some complicated indexes. It's just kind of tricky to keep track of all the things you're holding on to in this question. It just gets a little bit hard with just a level of factorization, I imagine, just to obscure the answer a little bit. On to part 2. Again, it's like show, maybe too many shows, but Yeah, the onus is on the student to get to this answer, right? So show the substitution of the 0 in and show the substitution of that 6 into the formula for standard deviation. Fun fact, if you find the third derivative, it will find a measure of the skewness of the distribution, which is pretty fun. Hey, down here, this question kind of makes me a little bit sad because in here it says that the number of responses was like 0.683. Can you work out where that comes from? It's a normal distribution. Everything's normal within one standard deviation. Like you just go, bam, outside, you get your 234% and done, right? I thought this is a nice question just because, like, again, I think complexity in probability mass functions are really challenging. So the idea of using the standard deviation to get out to those limits, then also having to round because of the discrete nature, then having to go to my table and work out which ones were there to get the total probability.
Was the marks really low for that?
Yeah.
Because they can come back in there having done none of the rest of the questions.
Yeah, great.
Got it from the table.
Hey. Yeah, like you can imagine, like the plan, like all those values are already in the table, so they can still get into it. They can still get into it at any point. Like, there's a lot of effort, obviously, made by SACE to like get as many entry points into these questions. Yep. But yeah, 68%. It would have been beautiful symmetry if like the average was 68% for that question. That would have made me happy, right? All right, the last question. I do like this question. I thought this question was a little bit pretty. That sounds a bit sad, but that's how I feel. I would say this though, at the beginning of these questions, particularly the last question, like a lot of my students just go like, the last question, I'm done with it. But like, there's a lot of like simple, easy marks, always in all last questions. So don't just give up. Like, try to get those easy marks out of it. Like this, the beginning of this question is like a question 2 kind of question, right? There's some real like draw some rectangles, find some areas of things, right? It's not that particularly challenging, right? I can kind of see. I was talking about it last time. Like they comment that lots of like the area calculations were done of width 3. Can you see it? Like from 0 to 3, or a width 1, which you can see from 0 to 1. So they like, lots of strange calculations around the width here, and yeah, that happened. Then at the bottom here, an integral expression for the area. I think the plan of this was to like write some integral expression here with the hope that you could calculate that in your calculator and get a decimal representation of it. And when you get to the end of this question, like I will before they kick me out, when you get to the end of this question right at the end, like you could compare your answer and just check if it's actually matching your decimal representation in a nice way. So over the page, so here, just a basic derivative question. And once you, for you new teachers, once you get familiar with this course, you see the question asked that is coming a mile away. You see a derivative and you see an integral symbol right below. I was like, damn, I'm just going to use that to go back. And one of the teachers I used to work with always used to say, as soon as you see the type of question coming, right underneath that line, the integral of that goes back to the answer straight away. So this question's been, I think, even in some old exams, this exact same derivative. So it should have been pretty basic. But the question after it definitely hasn't been, because this is tricky. This is like really a really tricky question. You have to build this thing up. You can do this in 2 different ways. You use the integral that you have above to isolate the integral of ln of x dx out, right? So you have that as like your starting point. And from this point here, you could either go in 2 different ways, right? So you could start with your answer of ln of 2x squared and break it into pieces, right? And flatten it, and then perform the integrals that we need. Like ln of 2 is just a constant, so the integral of ln of 2 is ln of 2x, right? Sorry, in brackets, ln of 2 brackets x, right? And you can build this thing up pretty quickly like that way. Or you can start like I call this the additive model, where you start with ln of integral of ln of x, you double it, or you add an extra ln of x, integral of ln of x dx to both sides, right? And then I add the integral of ln2 to both sides, and I bring that thing together and build up the thing the other way. Both these methods were definitely implemented, along with many other mysterious methods that generally, long as they're mathematically sound, that's fine, right? I think that's really important. If you're a new teacher, don't have your solutions ready to go on. If a kid doesn't do your solutions exactly, they don't lose the marks. If it's a mathematically sound process, and they deserve the marks, right? This question, I never liked the SACE words around describing the relationships between 2 graphs because it seems so vague. I wish there was some more like stronger words we could like use here, but this seems to be like the wording has been grandfathered in for a long time. It's like, so like it's just some kind of horizontal translation, 1 unit to the left or right, depending on which direction you're kind of going here. But the last question just got so much in it, right? There's a lot of good stuff here. I'm only 3 minutes over time at this stage. So you have to like, look, the clever student actually read the question, just didn't try and throw maths at it. Like there's a lot of signposts, isn't there? Like it says use your answer to B part 2 and use your answer to part C. So it's like, oh, it must have something to do with that translation. It must have something to do with that integral, but things aren't quite matching up. There's a lot of kind of things that don't quite match up, right? So you had to realize with that there goes the air conditioner. With the translation, there's no change in area underneath this curve because it's a horizontal translation. So if I can find the area underneath the equivalent function and just move my limits over to match it, I can do what I need to do here. I think it's pretty nice, right? It's got some good level of complexity. It's got some careful algebra in the middle of it around like multiplying out the 8 through by the 2 and just little things like that. But it had that nice little kind of safety check that when you get to the end of this thing, you could compare it back to this like original integral that you would have written down here and be like, it's the same as a decimal representation. Oh, that's it, people. I talked a lot. Cool. Thank you very much. If you've got any questions, hang around. I don't mind answering any questions if you have anything.